Hey guys, so a couple of weeks ago I needed to set up a brand new TypeScript and GraphQL server from scratch. And here was me thinking that the JavaScript ecosystem had somehow stabilized, but clearly I was being optimistic. I just kept running into errors at every single step. TypeScript not compiling, incompatible Node.js versions, GraphQL files not being recognized. It seems that with the introduction of ESM modules, there are tons of issues with the popular NPM packages. So after finally getting it running, I figured I'd share a basic working setup with you. So this is how to build a modern TypeScript and GraphQL server from scratch. I'm using VS Code, but please use any editor of your choice. You can follow along line by line or just watch the video and download the finished repo in the video description afterwards. All right, let's do it. So we'll be setting up a new project from scratch. Normally I would use Yarn, but let's just stick with NPM today. It doesn't really matter. And just to note, I'm using Node version 20, which at the time of recording is the stable version. We'll start by creating a new directory for our project. So let's mkdir GraphQL server. Call it whatever you like. We'll cd into that. And since we're running TypeScript, we need to install the dependencies for that. So we'll go with npm I TypeScript. We also want the compiler TSC. I'll explain more about that in a minute. And then we want the types for Node.js. And we need to just install those as dev dependencies because we won't actually need them in production. So let's hit enter on that. And now let's look at our package.json. Okay, so all we have at the moment is our dev dependencies. I forgot to run npm init, so let's just do that now as well. npm init, which will add all the extra stuff to package.json. Let's just move scripts above dependencies as well. This is just kind of the order that I prefer having it in. Obviously, you can change it to whatever you prefer. Let's start by creating a new folder called source. This is where all our code is going to sit. And for now, let's just create a new index.ts file. Now, just a note on the dependency we installed earlier, TSC. So previously, if you've run TypeScript projects on Node before, you might have used tsnode. But in the latest versions of Node 20 Plus, I've found that this has just been a pain in the arse. The amount of errors that I keep running into trying to compile with ES modules has just been ridiculous. And then so I heard about another project called TSC, which stands for TypeScript Execute. TSC stands for TypeScript Execute. It's a Node.js enhancement to run TypeScript. So you can literally just run TSC, point it to your TypeScript file, and it should just work. So let's give it a go. So back inside our package.json, we'll create a new script called dev. And here we'll do tsc, point to our index.ts. So hopefully I can just run that now. Let's give it a go. npm run dev. So we need to change the source to source/index. That's actually where our file's sitting. Okay, perfect. So let's just write a random console log in here to see that it's actually working. Hello world. Great, so that executes without issue. Now, we also do want a tsconfig file just so everything is going to work as expected. There is a recommended TypeScript file available in the docs. So here the recommendation, we'll just add this to our repo as well. So create a new file called tsconfig, paste that in as is. We won't need to change anything. Now, let's just double check we can still run our code. Perfect. So now all the TypeScript stuff is set up. We actually want to install the GraphQL dependencies as well. So for that, we need a bunch of things. We need GraphQL, GraphQL Yoga, which is going to be the server I'll use today, and GraphQL import node, so we can actually import GraphQL files, so files with the extension .graphql into our TypeScript code as well. So let's install those. npm I GraphQL, GraphQL import node, and GraphQL Yoga. Okay, great. Let's just check out our package.json to make sure those are installed. Great, so we have all of those dependencies as well. Now we can configure a GraphQL service as well. So importantly, the first thing we want to import is import GraphQL import node. That's a mouthful. The reason for this is that when later we want to start importing .graphql files, they won't have an issue with this import in place. So we can just ignore it for now, but just put it there. So the second thing we want to import is create server from HTTP. You might want to use Express for this. In fact, I do recommend you use Express for this, but just for this demonstration, I'm going to use Node HTTP. Then we can import create yoga from GraphQL Yoga. And then let's start by creating a new instance of yoga. Then using our create server method, we'll create a new server, passing yoga in. Don't need that. And then we can just do server listen. So this should be the minimum setup needed to run a GraphQL server with Node.js. Again, I recommend you use something like Express instead, but for this demonstration, create server from the native Node module is absolutely fine. So now we have a server running on localhost 4000, and there we have it, a GraphQL Yoga server. We can visit GraphQL, but we don't have any schema set up at the moment, so there's nothing to query or mutate. And we'll do that next. So let's create a new folder and just call it for now GraphQL. And inside here, we'll have our schema.graphql and then our resolvers TS file for that. So let's just define two basic types. So we'll have type post, which has got an ID, title, content, and then we'll have a type user as well. ID name, email, and then let's just relate user to post via author. And then let's have a query to be able to fetch all posts. So we've got two queries here, one just to fetch all posts and then one to get a post by ID. Then inside resolvers, we can define the resolvers for that. So we have query, which was to get the post, and then another resolver to get the posts as well. Just leave those empty for now. Then we want to set up a nested resolver as well, so we can get the post author. We'll default on that. So now we need to import our resolvers and our schema into Create Yoga. So to do that, we need to import another module from GraphQL Yoga called Create Schema. Here we will pass in both the GraphQL type defs and the resolver. Let's create schema. Let's import our type defs to start from GraphQL, schema.graphql, and then import our resolvers as well. And then pass those into create schema. And then we can pass our schema into create yoga. So let's restart our server, see what happens here. Right, at this point, we should be able to start querying things. So I'll do query. There we go, we're getting recommendations, posts. So now I'm getting ID, content, run that. It should just return an empty array. What's the error we've got here? Error cannot return null for non-nullable field query posts. Okay, so that means in our resolver, for posts, we need to return at least an empty array. So for now, I'll do that. Restart the server. Run that again. Okay, so now we get at least an empty array coming back. Perfect. So we have now the TypeScript server set up, the GraphQL server set up, and we need to connect it to some sort of data source. So in my case, I think the best way to do this is with Prisma. So let's install two modules so we can access some data. We'll do npm i Prisma and then also Prisma client. Obviously, you can use any ORM of your choice, but this is my preferred one, so I'll use it today. Let's create a new file called database, database.ts. Here we will do import Prisma client from Prisma client. And then we can create a new instance of Prisma client and then just return that default. So this is how we can access our database. Prisma also comes with a bunch of commands to be able to run migrations and generate the Prisma client because it's fully type safe. So it generates all of the TypeScript types that are needed. So inside our scripts, we'll add 3 new commands: Prisma migrate, Prisma generate, and types generate. We'll look at this command a little bit later on because this is going to use graphql-codegen, which we haven't installed yet. First of all, though, we need a Prisma schema. So let's create a new folder called Prisma. And inside here, we'll do schema.prisma. So you can, I think, generate this automatically, but I'll just write it manually for now. The first thing we want is a new generator called client, so we can generate our client types, provider being Prisma client.js, and then we can connect it to a data source. In this example, I'm going to use SQLite. Of course, you'll probably want to connect this to something like Postgres in the future, but for this small example, let's just use SQLite. I've pointed it to a local file called dev.db, so let's create that inside the Prisma folder as well, dev.db. And then we want to create two models for our users and our posts. I'll just paste these in and explain them. We've got two models, one for user, one for post, ID, email, name, and then the related posts. Created that or updated that. It's always good to add these kind of things to most of your models. And then we'll do the same for posts, ID, title, content, author ID. So the relation between user and post is going to be on the post table. So let's run our migrate script. So npm run Prisma migrate. Just press enter. We don't care what the migration is called. Okay, perfect. Inside Prisma, we will now have a folder called migrations. And this is where all the migration code will go. And we should see that dev.db is starting to get populated with the SQLite code as well. And that means that we can now start to use Prisma inside of our resolvers. Let's import Prisma from the database. Prisma.post was it? .find menu. And we'll just leave it at that for now. And then if we restart our service again, npm run dev, and then go back, re-execute. So we can see that we're still getting 0 posts, but crucially, it's now coming from Prisma, our SQLite database, rather than just returning an empty array. Now, earlier, you saw me add another script, GraphQL code generator. Once this is installed, we'll have fully type-safe resolvers as well. So I'll know all of the arguments coming into each of these resolvers, so I don't have to guess what they are or repeat any of the types. So we're going to create a brand new folder, a brand new file, called codegen.yaml. And let's just paste in the config. So let me explain this. So schema just needs to reference any GraphQL file in our system. So we're saying check inside the source folder, and any file that ends in schema.graphql is something we want to pick up. If you have more GraphQL files, which I recommend you do when you scale, this is the kind of glob pattern you want. In this example, I'm just using a single file for resolvers and schema. But if I was to build an application that was scale, I would not set it up this way. So I'll create some videos in the future to talk about how to scale GraphQL servers for larger projects. But for this simple example, this will do. So CodeGen is more general purpose, but we just want types for our resolvers. So we're going to need two plugins for this, Typescript and Typescript resolvers. And we're going to ask it to output the types to source types generated resolvers.ts. So we can import our generated types from there. And it means that we can just load it onto the resolver function and get all of our type-ins automatically. Now, looking at the config as well, I've decided to prefix all of the types with I, just to follow the kind of generic pattern in TypeScript. The default mapper is going to be partial as well, so we don't have to return everything from a single resolver, because we're going to be using nested resolvers to return some parts of the data too. For now, we don't want context type. I'll just comment that out, and we'll just ignore the mappers for now as well. Naming convention, I've just said for enum values, change case to uppercase. That's just a personal preference as well. So back inside the terminal, we want to install 3 new modules: npm i GraphQL-codegen CLI, Codegen TypeScript, and Codegen TypeScript resolvers. So the CLI is just the command line tool we're going to run, and then these are the 2 plugins that we've mentioned in our config as well. So these can also just be dev dependencies, so we'll do save dev. And once those are installed, let's just head back over to our package.json just to double check everything's installed. Yep, there they are. And now that's installed, we can actually run our new script, types generate. So back into terminal, and we'll do npm run types generate. And with that done, we should now have a new folder inside source called types generated and resolvers.ts. That means that we can now go back into our resolver function, and we should be able to import something called iResolvers, coming from types resolvers. And now this will automatically type any single resolver that we have inside the object. So now a couple of these are going to throw errors because the return type is now expected and we're not returning anything, we're returning void. So let's just fill this out as well. So we need to return prisma.post dot find, let's do find unique, where ID, and the ID we can get from the arguments now. So the second argument is going to be the args. So from there we can extract the ID, and we'll see that that is a string. So that's that resolver finished. So we could do the nested resolver as well. So root will be the root post, and then we can say return prisma.user.find unique where ID equals root.author ID. But we're going to have a TypeScript error here saying that the author ID doesn't exist on root, because root is referring to the GraphQL schema version of the post. So the version that we defined inside our schema. And you can see that post here just has author on it, not author ID. So we could access author.id, but that's not what we want. We want to be working with the type being returned from Prisma. So we can go back into our code gen and use mappers to say that anytime we come across user, use the version of user from Prisma, or anytime we come across post, use the version of post from Prisma as well. So we'll save that and we'll generate our types again. And then inside our resolvers, the error has now gone away because now root is referring to the information coming from Prisma, which is actually what it would be when the code's running. So we just need to hint to TypeScript what's actually happening there. So if we just run our code again and then re-execute, again, we're getting an empty array. So let's just create a simple seed script so we can actually see some data being returned. So inside Prisma, I'm just going to create a new file called seed.ts. And here we're just going to import the Prisma client and then just create a new function called seed async. We'll run seed, throw the error if there is an error, and when we're done, we'll just disconnect Prisma. Let's just create a little log in here saying that the seeding is started, seeding database, and then we will first of all drop all data in our dev database and create some dummy data as well. So we'll create some users and then let's just seed some posts. So we've got 5 posts, 2 users, and then we'll just have a little log at the bottom as well to say database seeded. Inside our package.json, we can connect that to a script. So we'll create a new command called seed, which is using TSC again, but pointing to Prisma seed this time. So we'll run that, npm run seed. Great, the database has been seeded. Again, we're using SQLite, so that would have just got saved against our file. And then we can do npm run dev. Now in GraphQL, if we execute, you can see we've got 5 posts. We can also access the author, ID, what else have we got? Name there as well. And there you have it. So that is the most basic version of a GraphQL TypeScript server you can get with Prisma database connected and using CodeGen to generate types automatically. If you like this video, please leave a comment and I will see you in the next one.